Hello students, how are you all? Welcome to yet another video on determinant and matrix chapter. So already we have started lecture series on previous year question and the topics from 12th HSC board. As board exam is coming closer, so we have started to uploading plenty of the videos on our channel. So if you are interested to see this video, you may check it into our playlist. Okay, so already plenty of the videos are there. Now in our today's video, we are going to learn one of the very much important topic for your board exam, which is for finding inverse, which is very much important. Okay, so there are several other way for finding the inverse. Okay, so within that we have to learn one method for finding the inverse, which is a minor cofactor method or adjoint method. Okay, so which is a famous method for finding the inverse. So that method we are going to learn in our today's lecture. So at the end of our lecture, we'll go for understanding some of the questions from the previous year board exam. So it will be helpful for clear your concepts. Okay. Now, welcome to yet another time on our lecture series, complete lecture series on 12th HSC board, previous year questions and their practice. Okay. So our today's complete lecture based on the determinant matrix chapter under adjoint and cofactor method. Now let's get start our today's lectures. So in our lecture, we understand first of all some of the basic concepts, okay, which are important here. First of all, we will understand the definition for singular matrix, okay. Then we'll go for the non-singular matrix, okay. We will first of all find it out what is meant by the singular matrix, okay. Okay, singular matrix. What is meant by singular matrix? Okay, the matrix which determinant goes to 0. Okay, the matrix which has a determinant 0, we call it as the singular matrix. Okay, and the matrix when it is determinant non-zero, then we'll call it as the non-singular matrix. Okay, and the singular matrix which is having another name, which is the invertible matrix. Okay, so invertible matrix. Okay, so this is the invertible matrix which has the same meaning like a singular matrix which has the same name as a non-invertible matrix. Okay, non-invertible means a singular matrix. That means the matrix which has a determinant 0. For finding its determinant, so if you wanted to see how can we find the determinant of a 2 by 2, 3 by 3 matrix, you may check it into my playlist. Okay, so determinant of matrix when determinant goes to 0. Now let me explain one short example. So if I consider one example 2 by 2, we'll go for the 2 by 2 only. Okay, so if we find the determinant of this matrix, so 20 minus 20, which gives us 0. Now here we can see the determinant of a matrix which goes to 0. Then we consider it as the singular matrix or non-invertible matrix. Okay, and now next part remaining, it is a non-singular matrix. Non-singular matrix means the determinant which goes to non-zero, or we consider it as the invertible matrix. Invertible matrix. Okay, so these two definitions are important here for our today's topic. So first of all, we have to understand them. Okay, now see here, invertible matrix. For invertible matrix, that means the determinant of matrix which is a complete non-zero. Okay, the non-zero determinant we consider as the invertible matrix. Okay, let me explain with one short example. Okay, you may take any example. Okay, so if when we find the determinant, okay, so what we will get, the 2 3s are 6 minus 4. So determinant it is a 2 which not equal to 0. Then we will consider it is the invertible matrix or non-singular matrix. Okay, now for finding the inverse of our matrix, we need the determinant of a matrix which is a non-zero. That means we want that matrix is a invertible or non-singular matrix. Okay, so we want the determinant of matrix non-zero, then and only then we can proceed further for finding its inverse. Okay, I hope you all have understood these two definitions from singular matrix and non-singular matrix. Okay, so in your board exam, instead of singular non-singular, you got the invertible non-invertible matrix. So don't get confused, the both are having the same meanings. Okay, So now let's get start our today's topic, which is inverse of a matrix using adjoint method. Okay, these are the two basic concepts we needed here, and whenever we need more concept, I will explain at the timing of concepts. Okay, so now let's get start our next part. So in our next part, we'll see steps for finding the inverse. Okay, for finding the inverse. So for finding the inverse, there are several other methods for our inverse finding, okay, which is one of the row transformation, column transformation, or adjoint method. Okay, but our today's lecture, which is completely based on the adjoint method, by using minor cofactor, we'll find out the adjoint. Okay, so for finding the inverse using adjoint method, we'll go for the steps first of all. Okay, so what is mean by inverse? What is mean by inverse? We need to understand it first, then it is easier for the next part. Okay, inverse means when we multiply any matrix by its inverse. When we multiply any matrix by its inverse, then we get the identity matrix. Okay, so what is mean by identity matrix? The matrix which a diagonal element is 1 and another it is a 0. Okay, so which is the identity matrix. Okay, so when we multiply any matrix to its inverse, okay, A into A inverse, we got the identity matrix. So then we call A inverse as a inverse of a matrix A. Okay, so for finding the inverse of a matrix, we'll see adjoint method. Okay, now for finding the matrix, first condition it is there, the determinant of a matrix, which is need to be a determinant of A need to be a non-zero. Okay, so we want the determinant of our matrix need to non-zero, and once the determinant is non-zero, then and only then the matrix which is the inverse possible there. Okay, so for finding the inverse, we have one standard result for matrix inverse of matrix A inverse, which is equal to 1 upon determinant of A into adjoint of A. Okay, now here it is the standard formula for finding the inverse of matrix. Okay, so A inverse it is here. So here we can see that if determinant it goes to 0, then 1 upon determinant of A, what will happen to 1 upon determinant of A? So we can say that it comes as a 1 upon 0. And in our mathematics, if we get the 1 upon 0, that term always remain as an undefined quantity. Okay, so we do not want the undefined quantity for our calculation. That's why we always take a determinant of A non-zero. Okay, and then after part it is for finding the adjoint of a matrix. Okay, so that matrix we'll use minor cofactor method. Okay, so what is mean by adjoint? Whenever we take the cofactor matrix transpose. Okay, so next condition, whenever we take cofactor matrix transpose, then we get the adjoint of matrix A. Okay, whenever we take a transpose of our cofactor matrix, then we get the adjoint of matrix A. Now you all are calling that, oh, what is mean by cofactor? Sir saying that the cofactor matrix is there and we don't know the meaning. So I will explain in a short term. Okay, cofactor matrix, it says that whenever we have Cij type of element, so we'll take as a minus 1 raised to I plus j into minor of ij. So this is the standard form that we use for finding the cofactor. Okay, so cofactor matrix, it looks like a element C11, C12, C13, C21, C22, C23, C31, C32, C33. Okay, so this is the 3 by 3. I consider here 3 by 3 matrix for finding its inverse. There is a 2 by 2 matrix also, another matrix for finding inverse, but our main target is to find out the inverse for 3 by 3 matrix. Okay, so this is the cofactor matrix. Whenever you use the result Cij and substitute the value here, you will get the cofactor matrix. Okay, so cofactor matrix, you can define it from here. Once you get the cofactor matrix, what we do, we take the its transpose, then we will get the adjoint of matrix. Okay, now for finding the cofactor, so you are calling that what is the Mij here? So what is mean by Mij? So Mij here as a minor, Mij here as a minor of a matrix. Once you get the minor for 3 by 3 matrix, then proceed for the cofactor. Take the transpose for cofactor, you will get the adjoint. Once you get the adjoint, substitute this value in our standard A inverse, you will get the inverse of our matrix. Okay, these all are the steps for finding the inverse of matrix. Okay, so we'll apply these steps in our example and then we'll verify how we can find the inverse of a matrix. Okay, so I hope you all have understood steps of for finding the inverse of matrix. Okay, and once you get the inverse of our required matrix, what we do, we substitute these values here. Okay, that means matrix A, we multiply its inverse, then we'll get the identity matrix. Okay, so this is the way to verify our inverse exists or not. Okay, once you get the answer for the inverse. Okay, so I hope you all have understood how to find the inverse of a matrix. Okay, using these steps. Okay, so we'll apply these steps on some of the examples which is based on previous year questions from our board exams. Okay, so these things are very much easier to understand. Let's move for some of the examples. Okay, which based on these topics. Okay, I hope you all have understood this one. Now let's move for the next part. So our next part, it is here some of the example. Now here we can see these examples are coming for 4 marks in our board exam. Okay, so what we do, we have to find out the inverse of matrix using adjoint and cofactor method. Okay, so once you come to understand how it is the process, then it is very much easier for finding their inverses. Okay, so it is all completely previous part that you have to apply all these steps for finding their inverses. Okay, so I hope you all have understood everything over here. Okay, now next part is to proceed only with the examples from board exam. Okay, these types of the examples are coming for 4 marks. Okay, nothing is difficult, you just have to try. Okay, with the only simple calculation you will get the easy 4 marks. So don't leave these examples. Always you have to grab such a easy examples, can make you higher score in your board exams. Okay, so I hope you all have understood. Okay, let's move for the next our example part. Okay, so in our example we'll understand detail adjoint method. Okay,